Okay, so now we are going to talk about numeration and mathematical systems, which is chapter 4. We're not going to do all of chapter 4. We're just going to do selected topics. That's the first thing. So what are numeration and mathematical systems? Basically, this means writing down how we count. And what we're used to doing is saying 1, 2, 3, 4, 5. Now, is this the only way to count? No. So let's go back in the day. Okay. So before we go back in the day, let's think about some of the things that we have in our number system. So first of all, our number system is called Hindu Arabic, based on its historical roots. So what are the important aspects of our system of writing down our counting numbers? First of all, we have place value. When we write down a 1 next to a 3, it doesn't mean a 1 and a 3. What does it mean? It means 13. And in a second, we're going to look at number systems that don't actually have that. What else do we have? We have the number 0. The number 0 did not exist for a long time. For a long time, when people thought about numbers and counting, they only knew how to start at 1. And writing down, the idea of coming up with a symbol, coming up with a symbol for nothing was actually a very big intellectual development in mathematics. Happened a long time ago, but it happened long after people have been counting for quite some time. So one of the important things about the number 0, using it for nothing, is that it lets us write, well, using 0, I should say, combined with the idea of place value, writing down a 2 versus writing down a 2, 0. Big difference. Two completely different numbers, right? So before there was 0 and before there was place value, this would have been a much harder thing to say. Okay. So I want to talk a little bit about, let me see, how do we, and I guess I should fill in, this is really, what I've started with here is 4.2. Okay. So one interesting topic, and some people have seen this, some people haven't, is how do you multiply two numbers by hand? Obviously, when I say how do you multiply two numbers, most people now will whip out the calculator. That's not what I'm talking about. I'm talking about how do we actually organize multiplication. So if I said multiply 723 times 564, no calculator, how would you do it? Right. Stack them, right? Okay. So 723, 564, and we're going to multiply. So what do you do? 4 times 3, and what do I write down? 2, and you carry the 1. Okay, now what? Right, so 4 times 2 is 8, plus the carried 1 gives you 9, and then what? 7 times 4 is 28. Next. Okay. Alright. So, quick review of multiplication here, I guess. Okay, so what next? Okay, so the 6. Okay. So and how should I mark that off?
Just writing the first
Right.
answer the other one.
Right. So what should I put over here? Okay. So some people put an X, some people put a 0. What would you guys like to put? Okay. We can't agree. I'm just going to put a 0. Especially because we just talked about 0. Okay. So next. 6 times 3. So what do I write down? An 8 and... Okay. So I want to remember there's a different one. Okay. So now... Right. And so what do I write down?
3 and then carry the 1.
Yeah, 3, carry the 1. Now, 6 times 7, which is 42, plus that 1 is 43.
So what's the number? 4338. Now, what are the numbers? This number. So it's a big difference, right?
Oh yeah. Well, all I'm saying is some people put an X there just to remind themselves to start in the next column. I mean, technically speaking, what you really got is a 0 there because this number is really 43,000 as opposed to 4,000. Does that answer your question? Okay. Okay, next. So what's the first thing I should write? 2 zeros. Now. 5 times 3 is 15. What do I write? Down to 5. Carry the 1 here. Now. Okay, so what do I write? Put a 1 here, and get a 1 there. And now, 5 times 7 is 35, plus the 1 is 36. And now, okay, and now what do we do? Add them. So that's a 2. This is 9 and 8. That's a 7. Carry the 1. That's 11, 12, 17, 7. Carry the 1. 6 and that's 7, that's 10, 0, carry the 1, and it's a 4. So it's 407,772, and we thought we'd never have to do that long by hand multiplication ever again, right? Okay. So what I want to show you is that there's a different way to write this down. This is called the lattice method. So this is how you start. Now first I want to ask, who has seen this before? Okay. It's honestly, I had never seen this before. Just like probably most people, most people were taught the quote-unquote traditional way to do it, and we never see an alternate way. Turns out that there are many alternate ways to write these things down. Let's take a look at this method. So what do we do? Okay, so first of all, you have to set up this. It's not quite a grid. We're going to call this a lattice. So the thing to recognize is, how have we made this? We've made a box, and you're multiplying 723, which you write across the top, by 564, which you write across the side. Now what you've got to have is a column for each digit in the one number, and then a row for each digit in the other number. You dig? Okay. And in each box, you've got to split it in half with a little slash line. And make sure you get the slash lines going in that direction, not the other way. Now, how are we going to use this to actually multiply? Right. We're just going to go digit by digit, or I should say digit pair by digit pair, and write the answer in the corresponding box. So let's just go ahead and fill them all in. Now, just because it's a little neater, I'm going to use the one that's written in black. So 7 times 5 is 35. 2 times 5 is 10. 3 times 5, 15. 7 times 6, 42. 2 times 6 is 12. 3 times 6, 18. 7 times 4, I heard it's 28. 2 times 4 is 8. Now the first box you could either leave blank, or what could we put in there? Or we could put in a 0, right? Okay. And then 3 times 4 is 12. Now the question is, how do we put this together in order to get the answer? Well, the amazing thing is that because of the way this is set up, each of these represents a place value. So, in order to combine all the numbers, we add, but we add so that all the proper place values are matched up. So, for example, add along that first short circle that I made, and what do you get? There's only one number there, so it's 2. Next, add along the next diagonal, 8, 1, 8, that's 17, so you put a 7, and we're going to carry the 1, which you can write it wherever you want. Let's see, I'm going to write it, where's a good play here? I'll put it there. Okay, now let's add all these numbers together. 1 plus 5 plus 1 plus 2 plus 0 plus 8, that works out to 17. So that gives you a 7, and the 1's going to carry over to the next diagonal. 2 plus 2 plus 1 plus 1 plus 1, that's a 7. Next diagonal, 1, 5, and 4, that's a 10. Sorry? I did. Check it. I did add it in, check it. Okay. The next diagonal is 1, 5, and 4. That's a 10, so that's a 0. Carry the 1. 1 plus 3 is 4. So where's the answer? It's right there. So if you put it all together, the answer is 4, 0, 7, 7, 7, 2. So you read the answer like this. So I want to question.
When you multiply 4 times 2, 8, why is 2
In the box. Okay, so yeah, we're going to talk about that right now. So I want to talk about 2 things. First of all, which method is easier? Do you like the first one because it's easier? Or because you're used to it? Exactly. Maybe that's a better question. Which one is quicker? Okay.
It's
All right.
almost the same thing with while you draw the thing and then do all the multiplication.
Yeah. This one is actually, without actually proving it to you, this one is quicker because there are fewer steps. Okay. So that's one thing that I wanted to say. The second thing is this magic, or why does this work? I also want to say that this lattice method is from India and Persia, which may be one of the reasons why it doesn't get taught all the time in this country. It takes a longer time. By the time it had drifted over, back in the days before the internet, it took a long time for information to travel. So by the time that the algorithm, or the way of writing it down that the Indians and Persians used, by the time it got here, we already had our own algorithm or method that we were using. Sorry? They used, yes, yeah. I know some people have seen this before, so it's some schools that actually teach this method.
Does it
But
only
yeah.
work for number with 3 digits?
Absolutely not. Works for anything.
So if you had like 4 digits and have 4 boxes.
However long each number is, that's how many. You put one number on each side, and if the number on top has 5 digits, then you have 5 columns. Number on the side has 4 digits, then you have 4 rows. And which brings up the next thing, which is did this magically work out, or is it lining up, or how did it line up? So the thing I want to convince you of right now is that it lined up in exactly the right way by design. So what this comes down to is, if you look at the answer, we need to get every number in the contributing to the right place value. So look at the easiest thing, and the easiest thing to look at is just ones. So if you think about the original 2 numbers that we're multiplying, where are we going to get our ones digit from? If you have, actually, let me stretch this whole thing out so you can see everything all at once. Where are we going to get our ones digit from? It's from the 3 times the 4. Yes?
Yes.
Okay. So how is that represented in the lattice? Well, where's the box that represents 3 times 4? It's in the bottom right corner. So when we start, and notice that, for example, our ones digit is going to be here. So what contributes to that? Only the ones digit from the 3 times the 4 problem. And that's exactly what we want. Does that make sense?
So the second one would be 8, 1, 8.
Exactly. So the next thing, and this is where it gets a little trickier, because the next thing we need to figure out is the tens digit. Now the tens digit from the answer, what's going to contribute to the tens digit? So look at the original problem. So what's going to contribute to the tens digit? Well, we're going to get contributions from 3 different places. First of all, first let's talk about the thing we just had. We just did 3 times 4. So that's going to contribute to the ones digit, but it's also going to contribute to the tens digit. To the extent that if 3 times 4 is bigger than 9, there's going to be, well, there winds up being a 1 there, and that's a 10. So it gets counted in the tens diagonal. Does that make sense? Okay. So next, where do other contributions to the tens place come from? Well, if you look at the original problem, 4 times 2. 4 times 2, this, if you think about where this goes in the answer, this 4 times 2, that answer went right there. We're really figuring out how many tens there are. Does that make sense? Because while the 4 is in the ones place, the 2 is in the tens place. So when you multiply them together, you're really figuring out how many tens there are. So the contribution from the 4 and the 2, is in, well, it's in this box, but we only want the units digit from that. Why? Well, let's think about the next one. The other place where we get a contribution to tens place value from is when we do the 6 times 3. So when we do 6 times 3, notice that we know, everyone said, oh, put an X or put a 0. Why? Because we know that we should be starting in the tens place. So 6 times 3 is going to be contributing to the tens place. But 6 times 3 is 18. Which part of that contributes to the number of tens that we have? Just the 8. Where does the 1 go? In the next column. And what column is that? It's the hundreds. So, notice the way that we have the lattice set up. The way the lattice is set up, if you look at, if you look at the 3 times 6 box, which diagonal, if you look at the diagonal where the 8 is, which place value is that? Follow it down. It drops to the tens place. What about the 1 from that 18? What diagonal is that in? What place value does that drop into? It drops into the hundreds. So this lattice has been set up in a very, very clever way, so that in each number, when you multiply 2 digits together, you're going to get a 1 or 2 digit number. And notice that the way that the lattice is set up is that each diagonal represents a specific place value, and each digit drops into exactly the right place value where it should be. So in the traditional algorithm, how do we keep track of putting something in the right place value? We either put 1 0 or we put 2 zeros, and that puts it in the right place value. How do we do it in the lattice? Well, the lattice does it for us, actually, by putting it in the right diagonal. Any questions? Yeah. No. Absolutely. Okay, so good question. So a 4-digit number by a 3-digit number. So let's say 5326 times 817. So 5326 times 817. Just go ahead and make your grid, and then you need to slash mark each box. And now just go ahead and do it. So what place values do we have? We have, again, we have the ones place here, we have the tens place here, we have the hundreds place here, the thousands, the 10,000s, the 100,000s, and the millions. Right. So that's really one of the beauties of the lattice method, is that it takes care of the place value for you. All you need to do is literally just make a column for each digit and a row for each digit, and it does the work for you. Okay, any other questions? Okay.